Picture this. More than 1,500 years ago, Indian astronomers are calculating eclipses, planetary motion, the rotation of the Earth, and the exact length of the year. And they're doing all of this without telescopes, without satellites, and absolutely no computers. They systematically mapped the moon into 27 distinct star zones called nakshatras. They built these giant, mind-blowing observatories entirely out of stone and developed mathematical astronomy powerful enough to predict celestial events with stunning accuracy. This, right here, is the forgotten science of ancient Indian astronomy. To really grasp how advanced this scientific civilization was at mathematically decoding the cosmos, we're going to look at its four main pillars: Aryabhata, nakshatras, the Panchanga calendar, and the Yantar Mantar. First up, the sky map, nakshatras and zodiac science. Now, through ancient texts like the Vedanga Jyotisha, these early astronomers essentially carved up the night sky. This kind of sidereal astronomy wasn't just for show. It was absolutely crucial for agriculture, predicting the monsoons, and timing specific rituals. So they created a system of 27 nakshatras. Because the moon takes about 27 days to orbit the Earth, it travels through one of these specific lunar constellations, like Ashwini, Rohini, Pusha, and Ravati, just about every single day. But they didn't stop at the moon. Simultaneously, they tracked the sky's ecliptic, that's the path of the sun and the planets, and sliced it into 12 zodiac divisions, like Mesha, Vrishabha, Mithuna, Karka, and Simha. Think about that. They seamlessly integrated a 27-part lunar map with a 12-part solar tracking system to create a rigorous mathematical grid of the cosmos. That brings us to time and calendars, the Panchanga system. You see, just observing the sky, that was only step one. Ancient India actually transformed astronomy into a massive computational system of timekeeping. They engineered both solar calendars, which track sidereal years, solstices, and equinoxes, and incredibly precise lunar calendars. But here's the catch. 12 lunar months don't perfectly equal one solar year. To fix this, they calculated these brilliant mathematical corrections to perfectly synchronize the two systems. And all of that synchronized math gives us the Panchanga, which literally translates to 5 limbs. It combines 5 elements: the Tithi, Vara, Nakshatra, Yoga, and Karana. This timekeeping algorithm is so remarkably accurate that these exact formulas still survive and are used in Indian Panchangas today. Just to give you an idea of how precise we're talking, a Tithi isn't just a sunrise to sunset day. It's a strict mathematical value based on the exact angular difference between the sun and the moon. And a yoga? That's calculated using complex planetary longitudes. Make no mistake, this is rigorous computational astronomy, not superstition. And then came Aryabhata, the man who quite literally changed astronomy forever. Back in 476 CE, Aryabhata writes a text called the Aryabhatya, and it completely shatters the old paradigms. While a lot of the ancient world firmly believed the sky just spun around a stationary Earth, Aryabhata states that the Earth actually rotates on its axis. He figures out that this rotation is what causes the apparent movement of the stars and creates day and night. Plus, he totally rejects mythological explanations for eclipses, proving scientifically that they are simply caused by geometric shadows in space. The guy just fires off a relentless series of mathematical breakthroughs, planetary revolutions, sidereal periods, and incredibly precise astronomical constants. To even make these celestial predictions possible, he develops advanced trigonometric equations and highly accurate sine tables. His planetary computations actually rival modern constants. And the crazy part is, this scientific tradition doesn't stop with him. You have brilliant successors like Varhamira, Brahmagupta, Bhaskaracharya, and Nilakantha Somyaji. They continue elevating this science, exploring concepts of gravity, and refining incredibly sophisticated planetary models for centuries before European astronomy reached similar conclusions. Next up, giant stone computers, instruments, and observatories. So they didn't just write these complex equations down on manuscripts. They actually built their astronomy directly into stone. To get true scientific precision, they invented physical observational tools. You've got the Shanku, or gnomon, to measure shadows and time. The Chakra Yantra determines exact planetary positions. The Gola Yantra is an armillary sphere that maps the heavens, and the Nadivalaya Yantra perfectly tracks the equinoxes. But this obsession with precision culminates in something truly epic, the Jantar Mantar. built across Jaipur, Delhi, Ujjain, and Varanasi. These aren't just buildings, they are massive architectural computers. Every single staircase, curve, and shadow is a static, giant instrument designed for naked eye precision astronomy. They track planetary movement and celestial mechanics with mind-bending accuracy. So, let's be clear. Ancient Indian astronomy was absolutely not mythology, pretending to be science. It was pure observation, mathematics, geometry, prediction, and precision, developed over centuries by astronomers who studied the cosmos with extraordinary discipline. From the nakshatras and the Panchanga calendar to Aryabhata's equations and the giant stone instruments of Jantar Mantar, India didn't just look at the stars, it calculated them. So the next time someone tries to tell you that ancient science was just primitive guesswork, just remember that centuries before the first modern observatories were ever built, Indian astronomers were already out there measuring the universe.